But that's exactly the time when it could do a maneuver to slow down and visit us. And one wonders whether this trajectory was designed by some extraterrestrial intelligence.
Something massive just slammed into 3I/A/TLAS. And what happened next left scientists and skywatchers around the world in total shock.
Better what the size of this object could be, the composition, the levels of activity. We're just bracing ourselves to get as much information as possible. We're really excited about this object. So far, we've discovered 3 interstellar objects.
Moments after the impact, the object began to glow intensely, radiating light like a powerful nuclear reactor and illuminating the dark emptiness of space. Experts are completely baffled, struggling to explain the phenomenon, while others are beginning to wonder, could this be more than just a random cosmic collision? Perhaps a mysterious visitor from beyond our solar system is watching us closer than we think. The collision event. The moment 3I/ATLAS was hit, something incredible happened. Its brightness did not just go up a little, it exploded over 1,000 times brighter than before. This was not a slow or gentle change like normal events in space. In an instant, the object went from almost invisible to blindingly bright, lighting up the darkness of space like a massive cosmic lantern. Every telescope, camera, and sensor trying to watch it was overwhelmed. The light was so strong that instruments could not record it properly. Scientists all over the world stared in disbelief. Nothing like this had ever been seen before. The impact released an enormous amount of energy. Temperatures shot up from the icy cold of deep space to thousands of degrees Fahrenheit in just seconds. The heat was so extreme that the material around the collision seemed to burn with the power of stars, sending waves of energy across the area. Experts calculated the total energy, and it was equal to the power of more than 10,000 nuclear bombs going off at once. The way the energy moved and changed was strange and unexpected. It did not match anything scientists had ever seen before. The sudden release of power was fast, sharp, and intense. Some parts of the light and heat acted in ways that seemed almost impossible. It almost looked as if the object might not be natural at all. The most astonishing part was what happened after the hit. Instead of fading, the object kept glowing for hours. The light stayed strong and steady, like a high-energy furnace floating in space. This was very different from normal collisions, which flare up and then fade quickly. The glow of 3I/ATLAS did not weaken. The heat and energy stayed constant, continuing long after the initial impact. Scientists could not explain why the object kept producing so much light and heat. Every observation confirmed that this was unlike anything they had ever seen in space. The collision of 3I/ATLAS became one of the strangest events in the history of astronomy. The sudden explosion, the enormous energy release, and the lasting glow made it clear that this was not a normal cosmic impact. The object transformed completely. What had once been a quiet interstellar visitor became an extraordinary, blazing, mysterious beacon in the darkness of space. Its behavior challenged everything scientists thought they knew about collisions, asteroids, and comets. The long-lasting brightness, the intense heat, and the extreme energy output suggested that 3I/ATLAS held enormous power inside it, ready to be released under the right conditions. Its unusual properties made it different from any asteroid or comet ever observed. The object proved that space could produce events that were both violent and beautiful, combining raw power with mysterious energy patterns. 3I/ATLAS left a lasting impression on scientists and the world. It was a cosmic event that combined incredible brightness, massive energy, and a steady glow, making it one of the most remarkable objects ever seen. Its collision reminded humanity that the universe is full of strange, powerful, and mysterious forces far beyond our understanding. The event will be studied for decades, serving as a reminder that space can surprise us in ways we cannot even imagine. but the mystery was just beginning. Scientists had to find out what hit it, and what they discovered was even more shocking than the explosion itself. The investigation. The collision with 3I/ATLAS happened in a very strange and unusual place. This part of space is almost completely empty, far from the asteroid belt and the major planets. Normally, collisions in space happen where there are many rocks, dust, and debris. The fact that something hit 3I/ATLAS here was extremely unlikely. Scientists called this the improbability problem. The odds of a random object striking it in such a lonely area were tiny, almost impossible. The location made it clear that this was not a normal cosmic event. Something very unusual had caused the impact. After noticing the strange location, scientists worked hard to figure out what could have caused the collision. They ran standard asteroid and comet simulations to try to recreate the event. Every single model failed. None could reproduce the sudden explosion, the enormous energy release, or the long-lasting glowing effect. The impactor did not behave like any normal object in space. Some scientists even considered that the energy might have come from 3I/ATLAS itself. Perhaps it had reacted in a way never seen before in the history of astronomy. Each test and simulation only made the mystery bigger and more puzzling. With normal explanations failing, scientists began exploring more unusual and exotic ideas. One theory suggested that another interstellar object might have collided with 3I/ATLAS. Even though the odds of this happening were extremely low, it could explain some of the strange energy patterns and the sudden explosion. Another idea was the binary object theory, which proposed that 3I/ATLAS might actually contain two connected parts inside. A collision between these two parts could have caused the sudden bright explosion and the long-lasting glow. A third, even stranger idea was the ghost impactor theory, suggesting that an invisible object, undetected by any telescope or sensor, struck 3I/ATLAS and caused the extraordinary event. These theories shocked scientists around the world. The collision showed that 3I/ATLAS was not normal in any way. The sudden explosion, the enormous energy released, and the persistent glowing made it one of the most unusual objects ever observed. The investigation revealed that this was a puzzle unlike anything astronomers had faced before. Every piece of data added more questions than answers, leaving scientists both fascinated and puzzled. The object's strange reaction, combined with its unusual location, created a cosmic mystery that pushed the limits of current space science. It became clear that 3I/ATLAS was not just another interstellar visitor drifting through the solar system. It was a rare and powerful cosmic phenomenon, traveling across space for millions of years, surviving the cold and emptiness, and then revealing energy and behaviors that challenged all expectations. Scientists continue to study the event, hoping to understand its origin, composition, and energy patterns. 3I/ATLAS reminded humanity that the universe is full of strange, powerful, and mysterious forces, capable of producing events far beyond our imagination. Its collision was more than a cosmic impact. It was a lesson in the extraordinary possibilities of space. With no clear answers about the impact, scientists turned to the object itself. What they found about its origins would only deepen the puzzle and raise bigger questions. The object's origins. 3I/ATLAS is only the third interstellar object ever detected near Earth. The first was Oumuamua, a long, strange rock that passed by in 2017. The second was Borisov, a greenish comet observed in 2019. Like these objects, 3I/ATLAS moves on a hyperbolic path, meaning it came from outside our solar system. It is not held by the Sun's gravity and is a true visitor from another star system. Scientists quickly realized that this object was rare and special. It is not like normal asteroids or comets that orbit the Sun. Its journey from far beyond makes it a unique object in our skies, one that challenges what we know about space. The journey of 3I/ATLAS is almost unimaginable. It may have traveled through space for millions of years, moving silently through the darkness between stars. Its path points back toward the constellation Aquila, a region filled with many stars. The star it came from is now unknown. Over millions of years, it may have drifted away from its parent star, or the star may have changed, died, or moved far from its original location. This makes 3I/ATLAS a cosmic orphan, a lone traveler carrying the history of its long journey across the galaxy. During all this time, it survived the extreme cold and emptiness of interstellar space, remaining intact and unchanged until it finally entered our solar system. Its long journey may help explain why it was so strong, dense, and unusual when it collided with another object, creating a spectacular burst of light and energy. Before the collision, 3I/ATLAS had many strange features. It was several miles in diameter, much larger than most asteroids that pass near Earth. Unlike normal comets, it did not produce outgassing, meaning it did not release gas or dust as it traveled. Its surface was cold, dead, and completely still. Scientists measured its mass and found it had an unusually high density for an object of its size. These characteristics made it different from anything normally observed in space. It was solid, tough, and mysterious, a remnant from a distant star system that had survived harsh conditions for millions of years. The origins and features of 3I/ATLAS show how strange and powerful space objects can be. It came from far beyond our solar system, traveled for millions of years, and carried unusual properties that set it apart from ordinary asteroids or comets. Its size, composition, and density made it strong and resilient, capable of producing an extraordinary collision that stunned scientists and captivated observers around the world. This object is a reminder that the universe contains powerful, mysterious forces that can challenge human understanding. 3I/ATLAS is more than just a visitor. It is a cosmic messenger, showing how much we still have to learn about the vast, hidden reaches of space. Knowing where it came from was not enough. Scientists needed to understand what it was made of, and the results were stranger than anyone could have imagined. Composition analysis. After the collision, scientists studied 3I/ATLAS closely to understand what it was made of. Using spectroscopic analysis, they detected familiar elements like silicon and carbon, which are common in rocks and asteroids. But alongside these, they found heavy rare earth metals in amounts that seemed impossible. These elements are normally created in extreme cosmic events, such as collisions between neutron stars. The presence of these metals in such high amounts surprised scientists. It suggested that 3I/ATLAS had traveled through or formed in environments far different from normal asteroids or comets. Its makeup was both ordinary and extraordinary at the same time, combining familiar rocky materials with exotic elements from the most violent events in the universe. Another striking feature of 3I/ATLAS was its unusually high density. Even before the impact, it was heavier than expected for its size. This density hinted that the object might be compressed, storing immense energy inside it. It was not just a simple rock floating through space. It was a tightly packed, powerful object carrying energy waiting to be released. When it collided, this stored energy may have contributed to the explosive brightness and sustained glow. Scientists realized that the unusual density and exotic composition were connected. The rare metals and tightly packed structure created an object that was almost like a natural reactor, capable of producing enormous energy under the right conditions. Together, the spectroscopic results and density measurements made it clear that 3I/ATLAS was far from a normal space rock. Its chemical makeup showed evidence of violent cosmic events, while its compressed structure suggested that it could store and release energy in ways no ordinary asteroid could. This combination explained why the collision produced such a dramatic effect, with light and heat far beyond typical expectations. 3I/ATLAS's composition revealed that it was both ancient and powerful, a survivor from extreme corners of the galaxy. Its elements told a story of distant star collisions, and its dense, compressed structure hinted at energy locked inside for millions of years. This analysis confirmed that the object was a truly unique visitor, capable of astonishing events unlike anything humans had seen before. The unusual materials raised a terrifying question. What power source could create such intense, lasting energy? The theories that emerged would challenge everything we know about physics. The power source theories. One idea scientists considered for the incredible energy of 3I/ATLAS is a runaway fission reaction. The object contained unstable radioactive elements like uranium and possibly even heavier elements that humans have not yet discovered. When the impact happened, the extreme force compressed these materials, triggering a chain reaction similar to a natural nuclear bomb. This could explain the sudden and massive burst of light and heat that overwhelmed telescopes and sensors. Unlike a normal explosion that fades quickly, a fission chain reaction could sustain energy for hours, matching the long-lasting glow of 3I/ATLAS after the collision. Its unusual density and abundance of heavy elements made it possible for this natural nuclear reaction to occur. In this sense, 3I/ATLAS was like a cosmic battery, holding huge amounts of energy waiting to be released. Another, more unusual idea involves matter and antimatter. Scientists suggested that 3I/ATLAS might be a composite object, carrying a small pocket of antimatter inside normal matter. When the collision happened, the shield around the antimatter could have been broken, allowing antimatter and matter to meet. This would produce pure energy far stronger than a nuclear reaction. It could explain the intense brightness, extreme heat, and sustained glow seen after the impact. Containing antimatter safely would require very precise structure, suggesting that this object could have been intentionally designed. This theory is extraordinary, but it fits some of the most unusual observations from the event. Both ideas help explain why 3I/ATLAS released so much energy. One is natural, caused by radioactive elements and compression, while the other is exotic, caused by hidden antimatter. Each theory matches part of what scientists saw, from the blinding flash to the hours-long glow. Together, they show that 3I/ATLAS is far beyond a normal space rock. Its power is unlike anything humans have seen, making it a truly remarkable visitor from deep space. The energy stored and released by this object reminds us that the universe can hold strange, powerful, and mysterious forces far beyond our imagination. These theories were alarming, but the real shock came when scientists analyzed the object's behavior. What they discovered suggested something far beyond natural phenomena, something almost impossible. The implications: 3I/ATLAS has not behaved like any natural object ever seen. Its trajectory adjustments after the collision did not match any known gravitational models. Normally, asteroids or comets follow predictable paths influenced by the Sun, planets, and other bodies. 3I/ATLAS, however, seemed to make tiny course changes on its own, almost as if it could steer itself. Along with this, scientists detected a coherent, rhythmic energy signature coming from the object. The energy pulsed in steady patterns that are very unusual for natural space rocks. Together, these observations suggested that 3I/ATLAS might not be purely natural. Its behavior hints at advanced technology, something designed to manipulate energy and movement in ways we do not yet fully understand. The combination of controlled motion and patterned energy challenges scientists to reconsider what we know about interstellar objects. The effects of 3I/ATLAS were not limited to its immediate vicinity. The object's energy radiated across the entire solar system, affecting spacecraft, satellites, and distant probes. Sensors on probes far beyond Mars picked up unusual signals and bursts of heat. Even instruments near the outer planets recorded tiny anomalies in magnetic fields. The impact and energy release altered the magnetic environment of regions far from the object itself. It was as if 3I/ATLAS had announced its presence to the whole solar system, making its influence felt across millions of miles. Scientists had never seen an object capable of producing such widespread effects. The magnitude of its power showed that it was far beyond a normal asteroid, comet, or rock drifting through space. Perhaps the most startling implication is that 3I/ATLAS seems to be an active power source, not a passive object drifting through space. Its sustained glow, rhythmic energy pulses, and extreme release of power suggest it is broadcasting energy across the void, intentionally or not. This challenges long-held assumptions in physics and cosmology. Objects in space are expected to obey simple rules: gravitational pull, orbital motion, energy dissipation. 3I/ATLAS appears to defy these rules, forcing scientists to rethink the limits of what can exist in the universe. Its presence may also hint that advanced civilizations, or forces beyond our understanding, can engineer objects capable of surviving millions of years of interstellar travel while storing enormous energy. The object's trajectory, energy pattern, and active output are messages in themselves, evidence that the universe can produce phenomena far stranger than we imagine. The implications of 3I/ATLAS extend beyond astronomy. Its technology-like behavior, energy release, and systemic impact suggest new possibilities for physics, cosmology, and interstellar science. It shows that the galaxy is not empty or predictable, but filled with powerful, mysterious forces. This single object has challenged human understanding, demonstrating that, even in well-studied space, surprises await. Its passage reminds scientists that there are limits to current models, and that new physics, new technologies, or new forms of matter may exist waiting to be discovered. 3I/ATLAS is more than a visitor. It is a lesson in cosmic possibilities, a powerful, glowing mystery that has forced humanity to expand its view of the universe. It leaves an enduring mark on science, technology, and our understanding of what is possible in the vastness of space. 3I/ATLAS has shown us the universe is full of mystery, power, and surprises beyond imagination. Its glowing collision challenges everything we know about space. Stay curious, follow the latest discoveries, and explore the cosmos with us. Don't miss out on the next incredible story from the edge of our solar system. Subscribe and join the journey.